Welcome to Video 4, Accessing Number Knowledge. Direct modeling tools we just went over in Video 3 help children begin to develop a more abstract idea of quantity and may help them move from counting all to the more efficient counting on. In this video, we focus on moving beyond having anything to count at all. We begin to ask children to imagine how numbers change when they are combined and separated instead, and to rely on their growing knowledge of how numbers relate to one another. To prompt children to begin imagining amounts and recalling known facts, you can implement the fourth key instructional practice in this module. Provide opportunities to solve problems with hidden results. In other words, you create a situation where a transformation occurs, and the resulting amount cannot be visually counted. The key steps of these hidden result problems are: begin with a known, visible, and countable set. Hide that initial set from view. Perform a visible and countable transformation by adding objects to or taking objects from the initial set. Ask how many are now hidden. Consider giving children the option to use chips or other manipulatives to show you what they believe is hidden, rather than only answering verbally. They may be able to visualize the answer even if they don't have the words to express it. This is also a useful mechanism for multilingual learners to share a response with you. While sometimes children will use some form of modeling to answer these questions, you will also see children begin to call on their knowledge about how numbers combine and separate to figure out how many. We want children to begin using their developing knowledge about numbers and apply it to problem situations so they are easier to solve. Eventually, children will be able to rely on their recall of basic facts in this way. Sometimes the world sets up a hidden result problem for you, and all you have to do is point it out. For example, when children line up in the hallway outside their classroom to wait their turn for the bathroom, and you have a rule that only 4 children should be in the line for the bathroom at one time. That's a hidden result opportunity. If you know that Kaya, Malik, and Sandra are already in line, you can ask, how many more children should we send out to the line if we want there to be 4 children? Or if you open a new box of 6 color-safe markers, give out 4, and then put the box away in a drawer, you can ask, do you all think we have 2 markers left so I can give 1 each to Samina and Eric? Can we figure it out without looking in the box? There were 6, and we already gave out 4. Expect children's ability to handle these questions to vary widely. Some may not be able to follow these real-life hidden result problems very well, and may do better when the problem is directly modeled with small sets of objects on a tabletop. Some may need to work with a total no more than 3 in order to follow the thinking. It may also help some children to use objects that have a bit less interest. Chips or cubes, for example, may help them focus more on the amounts. Others will be ready to use their fingers to help them solve the problem, and still others will be able to access what they already know about numbers to solve problems with hidden results without needing anything to count at all. Your progress monitoring data for this module will help you think about the right level of support and challenge for each child. One last set of ideas and experiences that are very useful for helping children develop multiple ways to solve problems is represented by the 5th key instructional practice. Provide opportunities for children to see the different ways a single quantity can be broken into smaller quantities. To help develop their number knowledge, children need multiple opportunities to see the different ways a single set can be broken into many parts. 5 apples can be put into 2 bowls, with 1 in bowl A and 4 in bowl B. Or with 3 in bowl A and 2 in bowl B. 9 can be thought of as 2 and 7, 4 and 5, or 8 and 1. All are correct. The subitizing you have been teaching and your discussions with the children about different ways of seeing quantities will be helpful here. For example, some of your students may now be able to think of more than one way to show the quantity 4 on 2 hands. Here again, it is important to gauge the different levels of thinking children are ready for. For your youngest students, you might only be working with the ways amounts combine and separate within a set of 3 for quite some time. Then it may be useful to expand to include sets as large as 5. When you see that fewer children are struggling, you can move to the combinations of quantities that make up numbers all the way to 10. Getting familiar with the combinations that make 10 is especially powerful knowledge because it helps us work with our base 10 number system. Adding 8 and 12 is a lot easier when you already know that 8 and 2 will make 10. The basic addition and subtraction fact recall band of the developmental progression makes clear that truly knowing and understanding the number combinations up to 5 does not occur until age 4 for most children. This knowledge continues to solidify through age 5. Thoroughly knowing how the numbers combine up to 10 generally does not begin until about 5.5 years of age. So again, you can't expect this knowledge to just flip on like a light switch. It will take lots of experiences and some time for confidence in number combinations to develop. In the meantime, the problem solving you will work on in Module 4 touches on all the skills you've addressed in the previous modules. Subitizing, meaningful counting, and comparing magnitudes will all be put to use as children learn how to solve basic problems. Providing problems with hidden results and helping children become familiar with how smaller quantities are embedded inside larger ones are both important for children's learning. They demonstrate that the most basic purpose of addition and subtraction is answering questions. They also provide children with opportunities to model the math and help children begin to use their number knowledge to imagine how sets combine and separate. If you can, provide opportunities to solve problems with hidden results, and provide opportunities for children to see the different ways a single quantity can be broken into smaller quantities. You will set your students up to become competent and confident problem solvers with many routes to success.